Okay.
All right. Looks like we're up to, we got about 10 people, so we'll go ahead and get started.
Okay. Okay.
All right.
Cool.
So again, I'm just going to do a quick formal thanks. Thanks everyone for attending. We got, thanks for supporting the group here. And if you have any improvements or anything we can do better or things you like, don't feel free to email any of us, put something on that LinkedIn group. Anything, input's always important. So today we're going to have Karol Francis from Gistic talk about linear events to boundaries. Before we get to that though, I had to look up your favorite transformer because I didn't know how to pronounce the thing because I'm not a math whiz like you. Is it Voronoi?
Honestly, I have not looked up the pronunciation myself.
I did, but I've forgotten what it was. It was Voronoi.
Voronoi? I don't know.
Yeah, I don't know what it is, but I looked at what it was, and it looks like a drawing I would make, right? So that's about my artistic ability. But the Voronoi transformer. What was that, Bo?
I think maybe someone in the audience could tell us. It's more. I think it's Italian, right? Or maybe French. Polygonalized.
Voronoi. It's like a type of pasta is what it makes me think of. Voronoi. I don't know.
I think that he's Russian.
Oh, so
because it's Voronoi, Voronoi is how is his actual last name. So anyway, Carol's gonna touch base on that. So we know what her favorite transformer is. I'm assuming you're using that today.
I am. You guys are going to learn more than you ever wanted to know about the Voronoi transformer.
And then your least favorite food, which is our other question, so everyone knows, is bananas, right? I know one other person that doesn't like bananas, but
they're horrible.
But do you like banana bread?
I can tolerate it.
Okay, all right. So, so with that, I'll go ahead and. You want me to read your bio, Carol? You want to just tell about yourself?
I don't even remember giving you a bio, so yeah, I'll tell you about myself. So hi.
Why don't we do that? I'll turn it over. I'll turn it over and turn my camera off. So
sure. So I'm Karol Francis. I'm a senior GIS analyst at Gistic Research. I've been here for about 1.5 years now, and yeah, so that's me. I'm here to talk to you guys about using Fme to generate polygons from non-spatial events. And before I get started, I'd like to do an informal poll. I hope you guys can all find the chat box and tell me your agency's preferred definition of boundaries. Are they polygons, non-spatial, linear, or some other format that I didn't list? While you guys are typing, hopefully you've all found the chat box. For me, it's hard to find it in Zoom. I don't know what my problem is. So for me, for people outside of the GIST world, may not understand that we can define boundaries using linear events and that they do not necessarily have to be in polygon format. And as I said, I'm pretty new to Gistic and the LRS world in general. And before I started working on this process in Fme, I had only been working with LRS data for about 6 months. And I thought Bo, who is the owner of Gistic Research, I thought he was totally nuts when he told me that he wanted me to take a CSV file and generate polygons from it. It sounded impossible. It seemed like he wanted me to do some sort of crazy GIS alchemy and attempt to spin gold from lead. And, it just sounded bonkers. So here, I'm going to take a look, see if I can expand the chat window. So it sounds like most of you are using polygons, and well, we work with ADOT a lot, and they actually do linear events for the most part, but they do have polygon representations also. So we know that we can overlay routes with polygons to get a linear event boundary file. In Fme, you can use this by using the line over area overlayer transformer, but what about going the other way and taking events, non-spatial events, and generating polygons? So that's what I did. And I'm here to talk to you about how we did this for ADOT and our process that actually successfully performs GIS alchemy. So here, within ADOT, the authoritative source of maintenance boundaries lies in a non-spatial flat event table that resides outside of the Esri Roads and Highways ecosystem. And we had a need to capture this data and its changes in roads and highways as linear events for analysis purposes. There are also customers who want polygonal boundaries, and for visual representation and spatial analysis. And we, the Gistic team, we also use these polygons for data visualization and dashboards. And so the polygons that ADOT uses that represent their maintenance boundaries, on a periodic basis, an employee would update these ownership polygons using a completely subjective and manual process. He would take the output CSV file that's a download from the system that stores these events, and he would draw polygons that looked right to him. And what looks right is completely subjective. It was completely manual. And about a year ago, the Gistic team, we started developing a process that used maintenance boundaries, and we needed something that was more authoritative than something that just looked right. So we realized we could help ADOT by creating an automated process in FME that would remove the subjective human component from the polygon derivation, and it could also be run at set time frames so that it was more consistent. And just to give you an idea of what we were trying to accomplish, over here on the right-hand side, this is a screenshot of the CSV download from the source table. And here on the right is the desired polygonal output that represents the maintenance boundaries. And this is actually a screenshot of our process. So I'll get to talking about what we did. And so before I really get started, I want to dive into my favorite FME transformer, which is the Voronoi diagrammer. And if you know how to say that word properly, I would really appreciate it if you could educate us all. This thing is really cool. And what it does is if you have a point data set, it will draw a polygon around every point in that data set. And of course, it maintains the attribute data about the points and transfers it to the polygons. And within these polygons that are drawn around every point, any area within that polygon is closer to the point contained within the polygon than any other point within your workspace. So this is the secret sauce that allowed us to generate polygons from our CSV or flat non-spatial data. It's really cool. Okay, so here we have sort of a big flow chart. This summarizes the Fme Polygonalization process. And that's a trademarked word that we invented at Gistic. There are 3 inputs for this process. The route and milepost layers are from the roads and highways database. And then we also have the non-spatial maintenance event layer. In the first step of the process, we use the milepost feature class to convert the LRM of the maintenance events from milepost and offset to route measure. And then we geocode that output to obtain event geometry, and this generates lines for us with a spatial component. Once we have the linear component, we then convert those lines to points, and that is because the Voronoi diagrammer requires point input. And then we plug it into the Voronoi transformer, which generates polygons. We have to clean up that output and dissolve and aggregate on the maintenance boundary names. And that's about it. And I would also like to point out that at several points within our process, we look for and log where we find data bugs. And we do find them, and there's quite a few of them. And we write these to an Excel spreadsheet, and using the emailer transformer, it then is emailed to the appropriate recipient who can then fix the data bugs that we find. Okay, these 3 screenshots were taken from critical points within the FME process. Each screenshot illustrates the same intersection, which is near where I live. It's where State Route 202 intersects Interstate 10 on the Phoenix-Chandler border in Maricopa County. And this screenshot here on the left shows the output of the linear output of the geocoder. And then we take that linear output and plug it into a chopper transformer that generates the points that it essentially just shows us where the vertices are on the lines. And then we take this point output and plug it into the Voronoi diagrammer. And the Voronoi diagrammer outputs these crazy looking polygons. And it looks totally nuts right here, like a spider web. But when we dissolve and aggregate these polygons on the maintenance the maintenance names, we get beautiful polygonal boundaries. And this is what we get. And it works and it's beautiful, wonderful. And then about a month ago, we made a major upgrade to the process. We started adding a new year of data to an existing dashboard, and we realized that we needed a temporal history of our maintenance polygons. So in the past, the subjective process where the guy at ADOT would draw the polygons, it wasn't run on any set schedule. And from what we could tell, there was no temporal history of his polygons. He may have saved them, but he wasn't putting them anywhere where an analyst or somebody who was trying to build a temporal history in a visualization could access. And furthermore, the authoritative database that stores the maintenance event information, it's not temporal. So we added a temporal component to our FME process so that we now have this temporal aspect. And so basically what we do is we take the output of the Voronoi thing and we compare it to what's existing in our database. And if we notice a change, we then retire the old polygon and generate a new one using the from date to date attributes, just like any other roads and highways maintained or managed feature class. And that's it in a nutshell. Excuse me, in a nutshell. And if you guys would like, I can show you this thing. It's a bit of a beast. Okay, have I tried Euclidean allocation of linear features? If so, how does that compare to the Voronoi method? So I have not, Kyle. That's a great question. It actually took some time for me to even find the Voronoi diagrammer. And I came across it because I was looking for Thiessen polygons, and just typing Thiessen polygons into the FME transformer gallery, it led me to the Voronoi method. So I have not tried the Euclidean allocation, but that is actually a great point, and I will look into it after this meeting and pull it up and see how it compares. Okay, so close this guy and cross your fingers. Okay, I'm going to go into the ADOT. I'm going to remote into ADOT. I will not be able to see this presentation, so please speak if you have a question so that I can hear you and interact with you guys. So let me pull this guy up. Oh, I lied. I think I might be able to keep you up. My gosh, this is so cool. I can actually see Zoom. Okay, so this is my workspace. It's actually pretty big. I have 206 transformers, but most of it is dealing with ADOT idiosyncrasies in their data and transforming. Yes, and as Eric says, we have a small group, so yes, please unmute, ask questions, feel free to interject. So we do a lot of stuff to manage the data and just get it into a schema and format that really works for our process. So the first thing we do is we have a custom filter that we apply to all of our workspaces within ADOT. And this is something that Bo came up with, and it's pretty fantastic. So we have the standard set of filters that we apply to any reader. So we want our mainline routes. We want all of our data to be current. We want where a local error is null because we don't want to pull in known bad data. And so that's that. We read in our milepost feature class here, and we read in our route network here. And then we do a little bit of cleanup to get rid of mileposts that don't really apply to our process. And then we filter our routes by milepost, and then do a little bit more filtering here. Down here is where we read in our non-spatial events. And you can see here that this is non-spatial, and the route name here it's not the same as a 32 character route name that is used within the roads and highways database. So we do a little string formatting and concatenation to get that 32 character name. And then we convert the 32 character name. Here we convert from milepost and offset to route measure using a series of joiners. And so we join, oh gosh, this thing is in the way. We join the milepost feature class to that non-spatial table on route ID and milepost. And from there, we're able to get the linear measure. We do that from the for measure and to measure. So we do it here. Do it again down here for the to measure. Just minimize this thing. Oh gosh, I undocked it. Okay. And then we geocode using this Lrs Geocoder, which is a geocoder that Bo developed, and you can download it from the Fme Hub. It's fantastic. You put in your route network and whatever event layer you have, and then it spits out spatial data. It's really nice. And then we take our linear events, and we plug it into the chopper. The chopper gives us points, and it zooms to the extent of Arizona, so you can't really see that it's points. You zoom in pretty far. You can see here that we have points. And then from the chopper, we go straight to the Voronoi diagrammer. And this is where it looks insane. And that's because there's a lot of polygons here. I will tell you the count of polygons when it's done rendering. 151,000 polygons, so it's a lot. But then we dissolve on district and org, and we get this, which still looks a little crazy.
Can I ask you a question?
Yes, sir.
And how long does it take, given the data, to generate the Voronoi polygons?
So it
5 minutes.
So it takes between 4 and 8 minutes and to run the entire process. And that is, the time difference is based on the change detection. If the process notices there's changes, it takes longer because then we write more data to the output. But if there's no changes, it takes right around 4 minutes to run.
But just for the Voronoi, you would think maybe take about half of the time?
Yeah, probably about half the time. I don't actually know how long it takes to run just this bookmark, but it's not terribly long, about 2 minutes for the entire state of Arizona. So once we aggregate, it looks crazy, but that's because it draws huge polygons around the points that are on the outside of the state. So then we clip to the extent of the state of Arizona. And that's how we get this guy. Okay, so now we have our polygons, and then we go to change detection, which is here. So I take the output and I split it between district and org boundaries. So a district is made of multiple organizations, but the process generates both. And then I also create linear events because it would be nice, instead of having non-spatial events, to have linear events for overlays and whatnot. So I split it into the 3 different types. And then I read the previous set of organizational, or excuse me, maintenance orgs, districts, and lines. And then we do a little bit of finagling to make sure that we have the same coordinate system on both inputs going into the change detectors. This change detector here looks for changes between the original and the newly generated information. And if it sees a change, then what happens is that we use this matcher to associate the new polygon with the object ID of the polygon that was in the previous iteration that's in the data set. Then we retire, and we retire the old one, give a new from date to the new polygon, and then we do a little bit of spatial manipulation, just so that we have the proper coordinate system. And we have to do a little bit of finagling because our Fme license does not allow us to write to SQL Server spatial. So we have to do a little bit of manipulation so that we can get geometry into our SQL Server. And then because we do not have write access to the roads and highways database, we actually put this into a file geodatabase that is not versioned. And so we take the output of the SQL Server, we read it again, we reproject it again to the proper Arizona projection that says AZ83 CIF, and then we write it again to this file geodatabase. So then anybody who has access to the ADOT system can then use these boundaries for whatever they need them for. And so that is that. Any questions?
Nobody has any questions yet? I have one comment about this. I
Sure.
had wrote down a question, but you answered it. It was, how do you determine the point on the line you want to use for but then I saw that you took the vertices of each road and then made polygons out of each vertice and then merged them all together. Did I understand that correctly?
Yes.
Okay.
Yes, so let me find the chopper. Where is he? Yeah, so we geocode and then we use the chopper, and we want one vertex so that Elizabeth, I'll answer your question in just a second. So we want one vertex so that we don't have short line segments. We just want a point. And then, yeah, that's it. So of course, this is not super scientifically exact, right? So this is definitely a derived data set, and ideally we would use it just for data visualization, for drawing maps or dashboards or whatever. However, we have been working on developing a different process for ADOT, where we're generating a highway log for them. And one of the dimensions that they would like their mileage divvied up by are these maintenance boundaries. And so we do use a polygon output for an overlay map, Elizabeth, with the highway log. And so it's just for summation. But it is also very much.
What's neat about this is that when I was at Iowa DOT, it was a long time ago, we have maintenance boundaries, and then there's snow boundaries, and having all these overlaps, this would have been a great solution. And if we had somebody that was always trying to draw these boundaries and they make a PDF, but to automate it would have been perfect, right? Especially if you have things like roads and highways or the road network that has those attributes on it.
Right. And now that we have this process, I'm thinking, I start thinking about other ways that we could use this. Like John is working on next-gen 911 information, and it would be nice to have zip code boundaries. And after talking to John, I didn't realize that zip codes are a linear feature class, much like these events, that it's not zip codes are not polygons maintained by the Postal Service, which all my life until maybe 3 weeks ago, I had assumed that zip codes were polygonal boundaries, but they're not, because, the mail trucks that drive on roads, they don't really care what exists off of the roads.
Huh.
So yeah. So now that we have this, I'm starting to think of other applications for this.
Absolutely. I think the key thing is from a data governance perspective, you need to look at the source of data. Which one is the authoritative source? And you can have different representations of that. In this case, in the case of ADA, and in the case of USPS, absolutely, zip code is actually for routing purposes. Then it is a derivation of the route using similar process that generates a zip code, right? And in the case of ADA, and the maintenance division, the operations maintenance division, they have never been truly GIS. That system has been there for over maybe 60, 70 years even. They define, they essentially assign road segment for different field crews. Now they call them organizations or groups, maintenance groups.
Units, I believe. Yeah.
Yeah. So that's the source system. But of course, we know as just people used to see the polygons as boundaries, and the manual process. The moment we realize they're doing the manual process, and we know, boy, this is some place that we need to figure things out. And Karol was able to pull this one off. We're pretty proud of her. And of course, this process needs to be used for all scenarios. Think about the county boundaries. County boundary has never been defined from the roadway segment perspective. So county boundaries and many of the political boundaries definitely needs to still be the polygonal boundary type. But for transportation purposes, oftentimes you have different authoritative source. I think I should turn on my camera too when I speak. Sorry.
Well, Kyle started it, so.
Okay. Yeah.
Good to see everyone anyway. So.
Yeah. And I think it's so valid, but still looking from which is the authoritative source, and we can accommodate that, and prove FME is perhaps the best approach to do that. Prior to use FME, we certainly looking to other process. I think Esri has a similar process of that, and we didn't give it that try because we're not as savvy with using Esri tools. So if someone in your audience would have a chance to try Esri approach, Fme Polygonalization Process, which is very similar, and would be nice to compare notes, I believe. Yeah.
Can you hear me?
Sure can.
Okay, yeah. So we did at KDOT, we did something called Euclidean allocation to, and it was very helpful in the maintenance area designation, just in finding problems. Like if you have a short segment with a bad maintenance segment ID on it, you can just search your polygon output. And if you sort those polygons by their size, you'll find very small sizes that you can say these probably aren't right. Let's review these and get these corrected. Euclidean output, that is a raster output in ArcGIS, so it gives you sort of boxy edges. So if this gives you smoother edges, that might look better. But yeah, it's definitely very valuable to have something. Your eyes on the map are easier. It's easier to understand the polygon representations than the linear features. And in the LRS environment, people are constantly changing stuff. It has to be maintained, and you won't notice if a small segment is missing or misallocated to the wrong. But you can quickly see that with polygons. So that's really valuable. In fact, we had some people, like we really would piss off our people who were trying to maintain the maintenance boundary shapes independently, in cartography from the linear referencing system. That was a nightmare. So automating this is really helpful. But I was wondering if you've explored, so what you end up with something like this with Voronoi is, or allocation is shapes that are kind of irrelevant to any other sort of jurisdictional boundary, and our ideal situation would have been to make those boundaries line up with political boundaries like counties, where they are not affected by the location of the roads. So yeah, so your polygons here are based on the allocation of area equidistant from the road center line, and that may be similar to county boundaries, but slightly different. If there's a way to snap those edges to a county boundary, that would have been desirable to the map viewers. But I never could figure out an easy way to do that. So I was wondering if you've had those same kind of comments or looked into that.
That's a really good question, Kyle. My understanding is that these maintenance organizations have absolutely nothing to do with county boundaries. They are completely independent of each other. So we have not even tried to snap them to county boundaries. So I don't really have any idea how they would lie.
That's a good answer. I agree that they're independent.
Yeah.
But historically, legacy-wise, that's what my answer was to those people.
Yeah.
But visually, it would have been nice to explore that further, and I never did because it's not valuable, except to those people who it's a change from what they've used to been, what they've seen, that's manually been maintained that way. And so anyway, we broke free of that, and I think that's fine. But I was just curious.
It's too bad FME can't fix culture sometimes, right?
Yeah.
That's a cultural thing. You're so used to saying it that's the county border, right? But then all of a sudden the jurisdiction is not, it doesn't match what you believe to be true. And so
I think it's the case in Ada, as Karol mentioned, they don't really care about county boundary because they are only concerned about state-owned road segment, right? So they're only concerned about the equal kind of allocation, so that their workload, around different districts to be more or less, in line with their whatever allocated, staff and equipment capabilities. So that they're concerned. But they do have, we do have districts. So it's district and boundary. So district is another roll-up of different maintenance orgs or crews, so to speak. So we do have another version for that. It's just a simple aggregation. Yeah.
Right. So yeah, this is our district, and then here are our organizations. So you can see that there are many.
And I think it's fairly true in DOTs that transportation districts generally will follow county boundaries and city boundaries per se, but maintenance boundaries, I from my experience have been, because you don't always stop your maintenance at a border, right? Like snow routes is a good example where you may, because of a turnaround point that's 4 miles or 8 miles into a county, you may then maintain that 8 miles of road that's in a different county. And this is where something like that would be really, really useful.
Yeah, so in Arizona actually maintains some roadways outside of the state boundaries. And so I don't know if you guys caught this, I actually buffer 2 miles around the outside edge of Arizona because we do maintain roadways outside. And that way, if somebody uses these polygons to make a decision, even though we hope they don't, because this is not as scientific as we hope, it's not as authoritative as we would like it to be. But this way they won't accidentally leave out those little bits of roadways that spill out in the state.
What about census data, the new census data? is that in polygons? Because in Iowa, they're doing broadband in the rural areas, and they hook that to the census data. So I could see this used for right-of-way analysis and for appraisal analysis using census data.
So
If you want to set up some kind of system.
Yeah, I have not worked with census data in many years, but there are some polygons for the blocks and block groups and whatnot. So, John,
I found that interesting that they took the legislature, they took the broadband
Mhm.
that you're trying to set up in the state, and they hooked all their geocodes then to the polygons in the census data. That's how they came up with their geocodes.
Oh, that's interesting. I'll have to read about that.
Yeah, that's interesting. I'll have to reach out to Patrick down in Des Moines, who may have had a hand in how that was done. I don't know if he doesn't have access to these types of tools. I wonder if he's aware of doing it this way.
Just another thought. When we did this in Kansas, it had a big impact on our bridge assignments for NBI, because as these maintenance boundaries shift, it was important to our bridge people to make sure the bridges were in the correct maintenance boundaries, because those assignments for NBI and bridge inspections were based on those maintenance boundaries. Have you encountered that? And also, how much do these maintenance boundaries change? Is this like an annual or a
So funny that it's so funny that you bring this up. So the dashboard that we were updating when we realized we needed a temporal history was our structures dashboard, and it uses NBI data. And to answer your second question, I don't actually know how often these boundaries are updated. I've been told it's frequent. However, I've been running it once a week for a few weeks now, and I haven't seen any updates. So I don't know. We'll see. We'll see. Yeah, I'm right now it's not automated. We do not, unfortunately, despite us asking for it very frequently, we don't have access to Fme server. So in order to automate this and to get it to run on a scheduled basis, we need to use Windows Task Scheduler, but I don't have the admin rights to get Windows Task Scheduler working. So my plan right now is I am running it once a week. And then when I'm really happy that it's actually retiring polygons the way I want it to, meaning I have seen changes in the source event data, then I will reach out to the IT people and get it scheduled. So yeah, I haven't seen the maintenance boundary changes yet, but
Does Arizona have FME server?
Oh, yes, we do.
Okay,
We've had it for at least 5 years,
okay.
but it has always been sitting on the shelf.
Okay.
You can consider there's a virtual shelf for the software to sit, collecting virtual dust. That is what's going on here. And we have been crying out for using for at least 3 years. So it's been just bureaucratic inertia sometimes. There's a separation of GIS infrastructure group versus GIS user group, and things just does not get done as soon enough. But I'd like to address on Kyle's question regarding how often. My observation is not very often at all. The district and maintenance organization or the maintenance org boundary changes is kind of rare, but it can happen anytime. We do not know, and if it happens, the old-fashioned of manual generation, that communication channel is pretty spotty. You never know if they will notify us, the GIS folks, hey, we have a boundary change. Here's a new dump of all the events. Go ahead, generate a new one. So the end result is we have a really, essentially unreliable version of the boundary. Could it be sitting there 2-3 years old? And because each and every time it's such a pain to regenerate that thing. So it's making it really unreliable. And this process even though, Karol run it on a weekly basis, we know we will really be able to capture the spatial temporal over the years, because by doing this, we become the only one having this temporal collection of boundary data for data visualization and data analysis purposes. Yeah.
So we did it, I think twice that I know of in 10 years at KDOT. And the first time was an organizational issue with the KTA and closing and merging some areas, some operational efficiencies. And then I think the second one was maybe based on how well the first one went. They might made some minor tweaks, and yeah, all it takes is a new division director or a operating director who wants to change something or something like that. So do your division of maintenance, are there people at a high level that are aware of your capability to now change this in a painless fashion?
We do work with the with managers in the motor planning division, or multimodal planning division. And so, yes, some managers are aware of this capability. I don't know that they really talk to people outside of their little silo. It seems like stuff is really siloed over there. So yeah, I did reach out to a developer in a different group a couple days ago because I noticed that we had some weirdness going on with mileposts that I was trying to determine if we had a problem with our logic, like was there a business rule we needed to implement, or was it a data bug? And he had no idea what I was even talking about when I tried to describe what I was doing. And so, yeah, I think that our audience within ADOT is unfortunately a little smaller than it could be, but hopefully word will get out that we're able to do this, because I think it's pretty cool and useful.
Yeah, I think a lot of those maintenance people probably know like where they turn their trucks around and stuff, and where to
Right,
pick
of
up their
course.
snowplows. But they
Right.
probably don't
Well,
want to
not in
deal
Arizona.
with technology people who are able to accurately represent where those turnarounds are and map them, unless they know it's going to be relatively painless for them to get something that's useful. So that's a lot of times where there's a disconnect. And just having this solution, if you show them and start showing them iterations of their changes of what they want, sometimes that's how you can leverage these maps and this information to support them better.
Yeah.
All right, we got the awkward silence. It was like conversations going, then it's like, hey, so do you mind if I share my screen?
Yeah, sure. Let me turn
I
off
think we
my
got some
sharing.
final let me see here if I can do it. Let me see here. Let's just share my browser here. Just so we get some, just so people can see this here. You don't want to see yourself. There you go. So you can see my screen okay? So
Yes.
All right. So that was awesome. I think that was a great presentation. So that's what on kind of the wrap up side. And if you got questions, please yell them out or put them in the chat. But yeah, thanks again, Karol, for everything, for doing this. That was a great presentation. So our next presentation, next presentation is going to be Dave from Safe Software. He's going to talk about kind of the basics of FME, take direct questions, stuff like that. Maybe I'll prime him to get into pricing of FME, just so you kind of understand what an investment is for FME, either to add it or expand it, that type of thing. And then Bo has in there, I don't know if it's John, Bo, I don't know whose idea it was for the happy hour, but somebody on Gistic side. They're going to be doing a FME and transportation happy hour on the first Wednesday of every month. So we'll get some information out. So if people want to meet up for that. Are we having beers during that, or how is that?
Oh, sure. It's all virtual though.
It's the middle of, it's like, what time is it? What time is it that you're having the happy?
Like
Well,
10 a.m. I
think
think.
Okay, well, there we go. It's 11 for me. We're good.
so I think the happy hour might not be a good wording here.
No, it's good. It's good.
It's good. I think it's fun. The key thing is the time. I would think usually people associate happy hour being at least after hour late, Friday afternoon, after hour we hang out. But because the virtual nature and people living all different places, I don't know how we can actually come up with a better time to do it.
I think that's a good time.
I really like to see, I'm thinking about we probably still need to shoot for after work hours. So maybe, people say, hey, maybe 4 or 5 o'clock central, right? Or 4 or 5 o'clock class, central, and then people accommodate if they can join. And but I do not think it's proper to be like around noontime because it's too early to be happy at the time.
Oh, it's not too early to be happy. So it's always good to be happy, right?
Okay.
Look, we got Kansas, we got 2 from Iowa here. We got let me see, Bo, you're not in Arizona right now, right? So and then Mike, where are you from, Mike and Elizabeth?
I'm from Chicago.
Okay, so you're the
Illinois.
one that put the Chicago Transit in there.
Yes,
In the chat.
and the funny thing is, I never even heard of FME before, so I'm going, what is FME? So yeah. So a lot of the stuff that Karol was talking about, we kind of do similar things, just using Model Builder, and we don't have roads and highways, but we have a linear referencing system that we built for our elevated rail lines. So we just run a process every night that updates the defects found on the structure and the track, and shares it out to enterprise portal app.
Yeah.
But it's interesting. I like attending these, even though I didn't know what FME is, because the whole Polygon thing really got me thinking about maintenance crews, and then when somebody started talking about bridges, that's a huge discussion for us, because if you're going to fix something on a bridge, you have to shut down part of the rail line where the electricity goes. You can't just do 10 feet of a rail line, shut that down. So this is really making me think about how we can do other things too for maintenance. So thank you.
Oh, excellent. So good. How'd you find us?
I got an email. I don't even know. I must be part
We spammed
of
you.
Yes. I always respond to all the spams.
Did you have your bank account number handy?
Yeah. What bank? It must be part of GIST with ASHTO.
Oh, gotcha. Okay. Yeah.
Yeah.
Yep.
So
Very
I got
good.
that today. So thank you. Very informative.
Great. Thanks. And Mike, I don't know if Mike's probably having lunch.
Oh, sorry, hi. I'm from the Texas Department of Transportation.
Okay. Yeah. Were you at GIST last week?
I was not.
Okay. You had some people there, because I can't remember who I talked to right offhand, but yeah, that's great. And then we have Jim. How's it going? Hope he's on mute still. So
I'm doing fine.
good.
There'll probably be some new members joining from the DOT out of the right-of-way section. We just hired a new planner that has a GIS degree, and she's going to join.
Good. Just always get us fellow Iowans on this, right? So there's a few states that are leaders in this, and Iowa DOT is one of them. So it's good. So excellent. All right. Well, does anyone else have any other questions or comments? And otherwise, we'll wrap it up here.
Hey, Eric.
Yes.
For Dave's speak, 20 minutes, I think I asked him to more focus on the linear referencing capabilities in FME. So it wouldn't be a really talk about the basic of FME. So that's if we need to have that, maybe have a separate session in the future.
That's fine. Yep.
Yeah.
I was just reading off the slide that you had there. He was talking about the basics of FME. So
Okay. Yeah.
yeah.
Most likely. Yeah.
Yep.
This type more the FME LRS related features. Yeah, in FME. So some of the future talking. So in June, we're planning. Eric has been communicating with the Connect DOT on their effort using FME. And we have another one lined up, really good one, a roundtable kind of like group discussion, talking about our DOT's years effort in implementing their FME server and systems in, kind of like DOT wide. And we can also talk about. I'm also trying to reach out to Utah DOT. They did some interesting work one time and to see what they do. I believe Georgia DOT has done something as well.
Yep. Yep. We'll
Georgia
get
DOT, and even Louisiana DOT. I had an impression we'll grab them to do a talk, and then Gistic can also talk about the quite a few LRS custom transformers we have posted on the hub. For free. These are free transformers that we use on a daily basis. We can identify a few and talk about how they can be used and why they're relevant, and see maybe people can start using those freely available LRS transformers for analysis purposes. So these are some ideas. If you have any ideas and suggesting, knowing someone is doing great work, especially in our domain, preferably, and let us know. We'll reach out and have them come and share their knowledge and expertise.
It's great. So, all right. So I guess we'll kind of officially close our meeting. No, thanks for everyone that's on, and keep following us on LinkedIn. We're going to be improving our communication, and that way we can spam more people, right? No. So hopefully we'll expand the group. I think we'll probably talk about trying to get the main group eventually get its own website or page or something. Maybe I'll talk to the folks at GeoDecisions. Maybe there's something we can do there. Or, but it's probably maybe easier for you because you have less bureaucratic process than I have. Right? just you can make the decision, right?
No, we have John, Carol. They're all passionate about.
Yeah, I was going to say we're starting to build in a little bureaucracy with the levels of decision making and disagreement.
There we go. So
I'd like to just add one more thing. We created a Google Calendar. It's on my most recent LinkedIn post on the group, and you can add that Google Calendar to your Google Calendar, kind of as like a second calendar, and you can see all the events coming up from the happy hour to the presentations. That way you guys can easier keep track of what's coming up.
it's great.
All right. Thanks, guys.
All right.
Good job.
Thanks.
Thank
Thanks,
you all.
everybody.
Thank you. Thank you. I appreciate it.
Yes, thanks a lot.
Thank you. Bye.
Thanks, Paul.